Hi everyone. So today we're going to be doing notes on section 4.8, which is the quadratic formula. So go ahead and take a second to pause and write this down. We're going to start off with a little bit of review. So I want you to simplify each of these expressions as review. Actually, I don't want you to. I'm going to do it with you. So just a little refresher on what it means to square something. So when we see 5 squared, where did my pencil go? There we go. When we see 5 squared, this is like saying 5 times 5, which is 25. Then the next one, negative 12 squared. Notice that the negative is inside the parentheses and this whole thing is being squared. So this is like saying negative 12 times negative 12. So a negative times a negative is a positive, and 12 times 12 is 144. Versus the last example where the negative is outside of the parentheses. So that means the negative just stays hanging out in front, and then the 4 squared is 4 times 4. So when I multiply this out, the negative still stays hanging out in front, and then 4 times 4 is 16. So there's a very distinct difference between the one in the middle and the one on the right. You have to pay attention to where the negative is. All right, now go ahead and write down the definition for square root. So the square root is, the definition of this says that the number a is a square root of b if a squared is equal to b. So basically all that means is, bring it down here, is saying that 4 squared is equal to 16 and negative 4 quantity squared is also equal to 16. So 4 and negative 4 are square roots of 16. All right. Now let's look at some examples. So we're going to start off with some ones that are already perfect squares, which means perfect squares are like 1, 4, 9, 25, 36, 49, etc. So 49 is 7 times 7. So the square root of 49 is 7. Whereas part B, notice there's this plus or minus out in front. So my answer is still going to have that plus or minus in it. And then the square root of 121 is 11. Then part C, this negative is out in front, so it stays out in front. The square root of 36 is 6, because 6 times 6 equals 36. Now this one is the one that's a little different. It's a fraction. So the square root of 1 is 1, and the square root of 25 is 5. So this is 1 over 5. But those are the easy ones. Those are the numbers that are already perfect squares. What I want to focus a little bit more time on is ones that are not perfect squares, which means there is no number that gets multiplied by itself to equal what's under the square root. So when that's the case, I'll write a little note. When you don't have a perfect square, you have to find perfect squares within it. This little abbreviation, the W slash means with, so this means within. So 27 is not a perfect square, so we need to find perfect squares within it. So 27 27 is made up of 9 times 3. 9 is a perfect square. So I'm going to circle this. This is a perfect square. Which means, what is the square root of 9? Good, you should have said 3. So 3 comes outside of the radical, but then this other 3 here is left over. We didn't use it. So that stays under the radical. Let's try another one, 48. The first thing that comes to mind for me with 48 is 8 times 6. Neither of those numbers are perfect squares, but those can still be broken down further. So 8 is also 4 times 2, and we just found a perfect square. And then 6 is 2 times 3. So we just found another pair, which will give us a perfect square. I'll write a little note for that. So these multiply to 4. So this is a perfect square. So what comes outside of the radical? From this 4, we bring a 2 outside of the radical. From this other one, the 2 times 2, that gives me another perfect square of 4. So another 2 will come outside of the radical. And then I'm looking at the bottom of all my little, I call these trees. So at the bottom of all my little trees, the only number left that I didn't use is this 3. So the 3 is the only thing left under the radical. And then I can simplify this, but let me go ahead and draw where these come from. So the 4 brings you that 2 that comes outside. Then that 2 times 2 gives us the other 2. Actually, I'll draw that little arrow for the 9 also. So 2 times 2 is 4. And then the square root of 3. All right, let's go ahead and do some where you try them on your own. So I'm going to have you do just the first 2 on your own first to check, make sure you're on the right track before I give you the other 4 to check on your, or to try on your own. So go ahead and pause this video, and when you're ready to check A and B, press play. Go ahead and check your answers for these first 2. Now I also want to point out there's more than one way to do these. If you looked at 24 and what came to mind was 8 times 3 or 12 times 2, that's perfectly fine. You can do either of those as your little tree instead, and then your numbers will just play out a little differently, but you'll still end up with the same answer. Same with 72. If what came to mind wasn't 9 times 8, that's completely fine. You should still end up at the same result. So for the 24, 6 times 4, 4 is a perfect square. Now you may have recognized from here that 6 is not going to break down any further and give you other perfect squares, and you could have stopped there at just 6 times 4 and written 2 rad 6. If you recognize that, you could have just stopped your little tree there. I chose to finish filling out the tree just in case you didn't see that. And then for part B, 9 is a perfect square, so that gives you the 3. 4 is a perfect square, that gives you the 2. And then at the bottom of all my trees, the only thing I didn't use is this 2. So that's what stays stuck underneath the radical. All right, I'm going to go ahead and show you the next 4 that you're going to try on your own. And again, There is more than one way to do these, depending on what you choose as your factors. So go ahead and push pause, and then when you're ready to check your answers, push play. Go ahead and check your answer for these. Now I'm going to walk you through my thought process while you check these. So part C, I chose to break it down as 2 because I look at this and I see it's even. I know 2 is going to go in no matter what. And I happened to get lucky, and my other number was a perfect square. It was 64. For part D, I recognize that 54 is 9 times 6, and I know 9 is a perfect square. And 6, I remember from my previous example, A, that 6 does not break down into any other perfect squares. So I just stopped there. Then for part E, I showed you how many different ways there are to do this. So this is what I was talking about. You may have looked at this and seen, well, 200, I know 50 goes into that 4 times. 4 is a perfect square, but then I can break 50 down even further. You may have broken 50 down as 5 times 10 instead of 25 times 2. Or for myself, when I look at this, I see 200 and go, okay, I know 100 goes in, and 100 is a perfect square. This is the one that I would have chosen to do. Or you may have looked at it and gone, okay, 200, I know 25 goes in, and 25 is a perfect square. But then it's 25 times 8, and 8 can be broken down further. It's honestly just a preference of your own personal thought process and how you look at this and what you recognize. But I highly recommend that you try to break these down so that they will give you a perfect square in what you're breaking them down into. So like for this one with E and F, it's so much less work to break this down as 100 times a number because 100 is already a perfect square. Every method is certainly correct and fine and gets you to the same result, but I choose to try to work smarter rather than harder. Oh my gosh. Work smarter, not harder. Because then it's less work and it's less room for making mistakes. All right, so those are your answers to those. Now that we've practiced simplifying, we're going to get to the actual quadratic formula. I wanted to focus more time on simplifying radicals because the quadratic formula is honestly just plug and chug. You're plugging in numbers where they go. The difficult part that students have trouble with is simplifying the radical once you get to the end of solving the actual quadratic formula. So, brings us to here, which is actually writing down your quadratic formula. So go ahead and pause this and write it down. So quadratic formula, this is the fun little song, The Pop Goes the Weasel, or the story. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So all we need to do is find our a, b, and c values, and we're going to plug them into the formula and then simplify it. So this radical, that's the part that I was talking about, is going to be the most challenging, is simplifying that. So example 1, or example A, I guess I would say, we want to solve this using the quadratic formula. But if we look at this right now, it's not in the right form yet. Oh, I forgot to mention that, sorry. It needs to be ax squared plus bx plus c equals 0. So right now, example A is not in the correct form. What do I need to move? Good, you should have said the negative 2, add 2 to both sides, put the c value over any variation of that. So I'm going to rewrite this so that the 2 is over here with everything else. So x squared plus 3x plus 2 equals 0. Now, for the sake of making sure we keep our values straight, I'm going to write down what a, b, and c are equal to. So a is whatever's in front of x squared, so 1. B is 3. C is 2. Also, side note, since I'm pointing with this finger now, super exciting. I was able to take the Band-Aid off. It's doing a lot better. I can still make it straight. I can still only bend it to here, and my finger is still numb, which is not good because it shouldn't be. So I called the doctor's office to set up an appointment. But it is progress that I don't have to have the Band-Aid on it anymore because it doesn't look scary without the Band-Aid on it anymore. Anyways, all right. We have our A, B, and C. We are going to plug those in where they go appropriately in this equation. Now, the other biggest mistake that students make is this negative B out in front. You leave off the negative. Make sure you do not forget that negative. It's really easy to forget, especially when your B value is also negative. All right, now for the sake of spacing and writing this nicely, I'm going to write this between two lines so that my numerator goes on one line, denominator's on the other line. So negative B, so negative 3, plus or minus the square root of B squared, so 3 squared, minus 4 times 1 times 2, so 4AC, all over 2A, so 2 times 1. All right, now for simplifying this, equals negative 3 plus or minus the square root. 3 squared is 9. We only have one negative, so it's going to stay minus. 4 times 1 times 2 is 8, all over 2. So negative 3 plus or minus the square root of 1 over 2. Now the square root of 1 is just 1. So negative 3 plus or minus 1 over 2. I wanted to give you a nice one first so that you can see easily how to break up this answer. So because this is plus or minus, when it's written like this and you don't have a radical, I want you to finish simplifying this because you're able to. You can finish simplifying this. So having this plus or minus here means you are going to have negative 3 plus 1 divided by 2 and negative 3 minus 1 divided by 2 for that plus or minus. So negative 3 plus 1 is negative 2, which is negative 1. And then negative 3 minus 1 is negative 4. And negative 4 divided by 2 is negative 2. So those are my answers. The way I'm going to write this on your homework is in those fancy little squiggly brackets. So squiggly bracket, and remember smallest to greatest. So the smallest number is negative 2, and then negative 1. Squiggly brackets. If you write this in parentheses or these square brackets, it will be marked wrong. You have been warned. So I'll write it on the actual note so you remember. This is not. Write it in big, giant letters. This is not negative 2, comma 1, or brackets, negative 2, oops, negative 1. It is not either of those. Do not write it with parentheses or brackets. This is a coordinate point. This is a domain or range. Actually, this is a coordinate point or domain or range. This is a domain or range. This, with the fancy little squiggly brackets, means it's a solution set. Let's look at another example. Oops, I didn't highlight B. There we go. So first thing I'm going to do is write my A, B, and C value. So A is 1, B is 4, C is 1. You don't have to write that if you don't want to. I personally always do just because it's easier to avoid making mistakes when I just look at my A, B, and C instead of trying to fish them out of the equation. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, go ahead and finish simplifying this on your own, and then push play when you're ready to check. All right, I'm going to go ahead and stop here and walk you through to the end. If you stopped here, totally okay. I'm going to walk you through how to get your final answer. If you continued going on, just keep watching to see if you did it correctly. So 12 is not a perfect square, but it does break down as 4 times 3, and 4 is a perfect square with the 3 left over unused. So I can write this as -4 plus or minus, bring a 2 out of the radical, because the square root of 4 is 2. The 3 is left over, all over 2. Now, this is where it gets a little bit tricky. A lot of people will leave their answer like this. Technically, if you plug it into a calculator, it's correct, but it's not fully simplified, and we need to fully simplify it. So having this addition and subtraction divided by a number, this is like saying -4 over 2, the denominator, plus or minus the 2 rad 3 over 2. If we were to split it up, that's what would happen. And if we do that, we can simplify those 2's, and we can also simplify this. And I am left with -2 plus or minus the square root of 3. Now, you may have been able to recognize that from here and see all 3 of these numbers are divisible by 2, but if not, you can always write it as 2 separate fractions. Now, when I write my answer, I will accept it either way of you writing either -2 minus rad 3, comma, -2 plus rad 3 in your little squiggly brackets, or, actually, space this out better, or if you put -2 plus or minus rad 3 in squiggly brackets, I will give you credit either way. Some people feel more comfortable splitting it up. Some people feel more comfortable writing it kept together. Me personally, I usually write it together out of sheer laziness of not wanting to write more. But I will accept it either way. All right, our last example is going to be one that's a little bit more challenging. We have other numbers that are bigger and not all equal to 1 or tiny numbers. So first thing I'm going to do is write out a equals 5, b equals 13, c equals -1. Make sure you're careful that your c is -1 when it gets plugged into your equation. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Go ahead and pause this, simplify the stuff that's inside the radical, and push play when you're ready to check. All right, you should have gotten to this point. You have 189 underneath your radical. Now, when I look at that at first glance, I don't recognize that to be a perfect square, but I'm going to show you how to do the checking in your calculator. So first thing I do is I'm going to check the square root of 189 just to make sure, because sometimes it'll be a bigger number. So it is not a perfect square. But I don't really have anything that comes to mind right away of what goes into this. I know that 2 does not go in because it's not even. If I use the trick with the 3's, I know 3 will go in because 1 plus 8 plus 9 is 18, and 3 goes into 18. But I want to show you a little bit better way. So 189 divided by 3, it does go in evenly. But I'm going to test this with perfect squares. 189 divided by 1 obviously goes in, but divided by 4 does not go in evenly. 189 divided by the next perfect square, which is 9, goes in evenly. So personally, I do it that way, where I check for perfect squares that go in first, so that I don't have to do as much work with my little trees. So I know that 9 goes in 21 times. 9 is a perfect square. 21, the only way that breaks down is 7 times 3, Neither of those are perfect squares, so that's my stopping point. So the 21 is what's left over. So when I write this, negative 13 plus or minus, square root of 9 is 3, so 3 comes out, and the 21 is left over, did not get used, divided by 10. Now if I look at whether or not this will simplify, 13 over 10 will not simplify, 3 over 10 will not simplify. I'm going to leave it as one big ol' happy fraction. If you prefer to split it up and write it as negative 13 over 10 plus or minus 3 rad 21 over 10, go for it. I leave it like this if nothing simplifies with the denominator. So my final answer, squiggly brackets, again, you can write this as two separate ones with the plus or minus, but out of the sake of laziness and less writing, negative 13 plus or minus 3 rad 21 all over 10. Close the fancy squiggly brackets. And that is our answer. All right, that's the end of your notes. Have a good rest of your day.